In this video, I want to look at expansions, compressions, dilations, and contractions. Now, I really only think of them as expansions or dilations, but let's take a look. To start with, we'll look at expansions and compressions. These are the terminology that this particular book uses. What's happening here is the point xy is being sent to the point kx, y. So either k is less than 1, they're taking k to be positive here. So between 0 and 1, in which case the x value is getting smaller, or k is bigger than 1, in which case the x value is getting bigger. It's really the same thing. I mean, if you look at the matrix, it's k0, 0, 1. This is what the matrix that achieves this transformation. And so, you know, expansion is stretching this way, or compression is stretching, anyway. If you multiply by a half, you're expanding by a factor of a half. If you multiply by 2, you're expanding by a factor of 2. So I still think of it just as expansions, although the book uses the word compression. Right? Also, the book is saying just use positive numbers for k. Now, the negatives we've seen already that if k, for instance, was negative 1, this would be reflection across the y-axis. The x-coordinate would become negative x, right? So it just flips it over the y-axis. Likewise, down here, when we're doing it with the y's, if k was negative 1, then you're flipping over the x-axis. So to make it so that it's like we're only doing one thing, we're not expanding and reflecting, they're saying just let k be positive. Personally, I'm okay with k being negative. I still see it, if k was negative 2, then this would be an expansion by a factor of negative 2 in the, let's do it with this one, in the x direction. So rather than expanding like 2 this way, you expand by 2, but then you reflect, right? So the negative sign just reflects it in the x direction. Well, that's if that one's negative. Down here, if it was a negative 2 here, then this would be expansion by a factor of 2 and reflecting in the y direction. Okay. We can do similar things in R3, but I don't know that I need to point that out here. Just one row. It looked like an identity matrix with one row instead of a 1 there. There's a k on that diagonal. But I do want to switch to dilations and contractions. Contractions, compressions, I can never keep track of those two words. I don't think of contractions as something different than dilations, as we'll see here. Again, we're going to be multiplying by k, but this time the whole thing gets multiplied by k. So the point xy is going to kx, ky, or the point xy is going to kx, ky. That either way, both the x and the y are being multiplied by k. Whether k is bigger than 0 or less than 0, I don't care. Don't care. I still think of it as dilation. I mean, when I think of dilation, the way I normally think of that word is eyes. People's eyes dilate, right? Their pupils go, they get big. That's dilation, the whole thing expanding. Not just one direction. It's not just expanding this way or expanding that way. It's expanding in every direction, okay? So this is what I think of as dilation. Well, if you're expanding, couldn't you be contracting? I mean, isn't that the same process, just multiplying by a number less than 1? Anyway, the book distinguishes between contractions and dilations. I don't. They are dilations with a factor of less than 1. Likewise, they're only allowing positive k's. If you throw a negative k in there, of course, both this k and that k would be negative, in which case you'd have a reflection both over the x-axis and over the y-axis. And the net effect is essentially rotating it around. So if you think about dilating by a factor of negative 2, right, that everything, well, you can think of it as everything expanding by a factor of 2 and then flipping, essentially gets rotated 180 degrees around. I don't know if I can do that very well. Flip it over the x-axis and over the y-axis. Right. In R3, it's only mildly different in that it's still k's on the diagonal here, But if k is negative, because the book doesn't allow k to be negative, but with k negative, that would be 3 reflections, one across the xy plane, one across the yz plane, one across the xz plane. And so you'd actually, if the origin is here, the origin is here, then every point gets reflected exactly to the opposite side of the origin, but the orientation is flipped because it's 3 reflections. Anyway, dilations and compressions are just multiplying each of the coordinates by a factor of k. It's essentially scalar multiplication. Right? So there you go. Dilations, compressions, expansions, contractions. If you want, just think of them as dilations and expansions. Expansions are in one direction only. Dilations are in all directions at the same time.